This time, it's all about performance-enhancing technology.
The thing just accelerates rapidly to 60 miles an hour. Wow.
And Zef sets the speed freaks a futuristic challenge.
It's got the power, it's got the potential.
The principles of speed may not have changed since the golden age of land speed racing, but the technology has. Computerized control units and the use of electric power have revolutionized how cars perform. It's these systems that will manage and maximize power delivery, handling, and traction in Zef's record attempt car.
This week, we want to explore technology and really see what we can use and understand for the future of tuning.
So Zef's going to set the speed freaks a challenge to find out how technology enhances performance in the hopes of being able to apply this knowledge to his record attempt. He's looking to the future by bringing the team an old-school Autobahn legend.
So I've decided to bring them a kind of classic car, really. But as usual, there's going to be a little twist to this car, and we're going to convert it into something 21st century.
But are the team ready to think outside the box?
What delights do we think Zef is going to bring us this time round?
I don't know, every week he brings us something else that's not as described, so...
Yeah, expectation, reality.
Zef.
What I want to show the team is how we can take an old classic car and put life into it. Show what it can do in the modern age. Hello! Hello again. Right, your next car, I decided to bring you some luxury.
It's large.
It's a 1998 Mercedes-Benz E300.
It's a turbo diesel, 3-litre straight six.
Okay.
It's got the power, it's got the potential. How about we get the car in and let's think what we can do with it.
He's brought out no surprises on this one. It's just the same old clapped out rubbish. Bring it in then.
When they first saw the car, they weren't enamoured. They think I brought them a car from the past, but this is about the future.
In its day, the E300 was at the cutting edge of turbo diesel technology. Its 3-litre engine produced 172 brake horsepower with a top speed of 137 miles per hour.
I'm thinking we scrap the whole drive chain, the whole engine, everything, and put in electric.
Okay.
Okay.
We've had no experience with electric cars.
Yeah, this is totally out of our box.
It's kind of something we've wanted to dabble in, so this is quite a cool concept, but I think we're going to need a bit of outside help on this one.
What's exciting about this project is that we're not going to build some kind of milk float with a 12-volt battery. This is going to be seriously kick-ass electric car. Bit of reading up to do, bit of cooling and some expertise, but we all know if we can master this and get the potential right, it's going to be an awesome car for today's world.
Before they can tackle this monster of a challenge, it's off to the Speed Freaks test track to see what this car can do as a diesel.
Okay, so we got the Mercedes E300 at the runway to test, so how about we find out what it can do?
Good luck.
Have fun.
This is a luxury Autobahn motorway cruising machine, so I've got some hopes for it.
Come on! 3, 2, 1, go!
Send it!
Oh, I think you need a push on that one.
Oh, it's struggling, very struggling.
Change.
And... nope.
Yeah, it's a little bit worn out. It finally changed gear. It's really lacking in power, this.
It's pretty embarrassing, really.
45, come on. I think I could probably pedal faster than this.
It's like watching paint dry.
We're struggling, pushing to 50.
Yeah, there's something wrong with that.
We finally hit 60. Oh my God, what is that? That has got to be the slowest car I have ever tested. It's at the end of its life. It's fit for the grave.
Here he is.
All right.
It survived.
Well, I can't get too excited by this one.
We were basically falling asleep on that line watching that.
It was slow. It was really slow. 28.4 seconds 0 to 60.
Oh my God.
There's definitely something wrong with it.
So our challenge is to do a full electric conversion on this car. I think it's going to be our most challenging one by far, but also the most rewarding.
Hopefully so, as long as it does actually go quicker than it did today, because that was an
Yeah,
embarrassment.
because today I did nearly fall asleep. All right, team, let's do this, yeah?
Yeah,
Come on,
let's do it.
back to the workshop.
When it comes to combustion engines, the Speed Freaks team are second to none. But battery packs and electric powertrains are a whole new world, so they've asked for some help on this one. Meet Chris Hazel. He specializes in electric conversions and will be supplying the new electric components for the Merc, as well as advising the team along the way.
So Chris, what are we going to do with this old Merc that we've got that is literally on its last legs?
So we're going to start off with the battery pack. We're basically going to build a battery box in the front of the vehicle that's completely watertight. And then we've got the motor, which is motor, inverter and gearbox all in one unit. So that wants to go in the rear.
Obviously, we need to remove the engine, all the gearbox and stuff like that, because that stuff is not being used anymore. So effectively, we need to work out a way of mounting that motor unit in the subframe to give the thing drive.
And then we've got the charge point, which pretty much you guys can just put with the original filler cap
Oh
on.
yeah, so it looks like when you're filling the car, you're
Properly.
actually filling it with electric.
Yes, just takes a bit longer.
Yeah.
We've got a small display, which gives us all our information, and we need to come out with some way of selecting gear. So whether you can modify the gear stick and just put two sensors.
That'd be really cool. It's an auto and it has like drive and
that's good
reverse. So once we've got all that mounted, we need to think of the drive shafts to the wheels.
The issue is the amount of torque.
Yeah, they're instant torque, that can break stuff, so we need to really think. Yeah.
Need a strong shaft.
Yeah. I'm glad we've got you here, mate, because I don't reckon we'd be able to do this without you. Let's go get the car.
Let's
Get the tape measures.
The team will first need to remove the diesel engine, gearbox and related parts. The heavy electric motor will be mounted to the back of the chassis and new drive shafts built to handle the massive increase in torque. The 240-kilo battery pack will be fitted into the engine bay and wired to the motor in the rear of the car. Coming up,
Let's go for it.
Zeph gets hands-on with the latest electric technology.
Wow, I mean, that's really night and day.
And the Speed Freaks team hit their first roadblock.
Nothing fits.
Zeph Eisenberg wants to be the first person to break 200 miles per hour in a car at Pendine. He knows his record attempt car needs major modification to cope with the challenge of speed on sand. And the man behind these modifications is Porsche specialist and engineer, Ibby. Work is already well underway on the Porsche. The engine has been sent to a specialist machine shop where it will be upgraded from 3.8 litres to 4.1, larger turbochargers and more fuel injectors added, pistons, conrods and drive shafts strengthened to withstand the additional power. While the engine is being upgraded, work starts on the cooling system.
I think that's this side. Yeah, that's this side. This is the other side. We're going to switch out the radiators. We're upgrading the radiators to a bigger coil, so it has more surface area. It will help with the cooling of the car on sand. Heat management is everything, basically, for us. We need to be able to maintain the heat, whether it's in the engine or whether it's in the cooling system. So it just basically preserves the life of the engine. You know, if a rad blows at high speed and you lose coolant, then the engine will overheat, and you'd basically have like a head gasket failure or an engine failure, worst case scenario.
The sand poses problems for many of the car's systems, including braking.
Yeah, these are badass. So we'll be removing the Porsche ceramic brakes off on the car. A worry that I have is when Zeph's racing on the sand, I think it's just going to get shot blasted. They basically deteriorate and they fall to pieces. That's your steel replacement. These steel brakes won't get damaged on sand because they're quite robust. Wow, these look awesome. Yeah, I like these. It's going to have good stopping power now, and we don't have to worry about the ceramics getting trashed to pieces. So yeah, this is perfect.
Lovely.
While Ibby carries on with the Porsche, the Speed Freak's set to turning an old turbo diesel into a fully electric car of the future. First, they need to remove the diesel engine, gearbox, and redundant parts in order to make room for the electric components.
Tess is there pulling out all the electrics, disconnect all the drive shafts, disconnect the engine mounts, and then we'll pull this sucker out.
This is a big old engine, lots of metal in there. It's like a tank. Onwards and upwards, and then hopefully there should be a big hole we can work with.
The space created by taking the engine out will be used to fit the battery box. The new electric motor will be mounted directly to the chassis at the rear of the car.
Oh my God! This is our new motor. This motor that we have to fit into the rear of this car is massive. It's bigger than an engine and a gearbox from a front-wheel drive car. It won't fit in between the subframe, so we're going to have to do a lot of fabrication, thinking on our feet.
The subframe may need to be modified to make room for the massive motor. Subframes are structurally very important. Not only do they strengthen the chassis, but carry key components like drivetrain, engine, and suspension.
We've now got the subframe out. That we're going to send away to be sandblasted. Tomorrow we can get on with working out 100% whether this is feasible, because we're still not 100% sure we can actually get this mounted.
Time for a little tea break.
Back to the studio. Walking out of shot.
While the team struggled to bring an old car into the 21st century, Zeph is on a research mission at Delta Motorsport, a British engineering firm at the forefront of electric technology.
We're at Silverstone today to talk to a couple of phenomenal engineers who have designed their own electric car from scratch.
The brains behind this car are Simon Dawson and Nick Carpenter, the engineers of electric test vehicle, the E4. It's compact, lightweight, driven by electric motors and powered by lithium batteries. This fully electric automobile has been produced to research and develop technologies like torque vectoring and traction control.
Hello, Simon.
Hi, Zeph. Good to see you.
Hi, Nick.
Hi, good to see you, Zeph.
The fastest cars on the planet all rely on the best electronics. I'm keen to find out how it can help the stability and control towards my land speed record car. We're about speed and power. And this car here is one of your babies that you've created to demonstrate power, acceleration, performance.
It's actually built as a development mule, if you like, so we use it for engineering purposes.
Now, if you were silly enough to take this beautiful car on the beach at Pendine, how are the computer systems going to help limit wheel spin with the amount of power you're putting to the sand?
So the electronic brain, if you like, knows how fast the vehicle is moving. So based on how fast the car is going, it can calculate the speed of each wheel independently, calculate then how much slip is going on at each corner, and limit the torque to each wheel accordingly, so that there's just the right amount of slip to give you the acceleration you want without just wasting energy and not accelerating.
A concern that a lot of people had, probably me as well, is that if you slide or you lose the rear on the sand at the crazy speeds that I'm going to be doing, you don't just spin to 360. The wheel could actually dig into the sand and you could 360 flip. How do you think you can prevent that happening?
When you have the ability to deliver a different torque across an axle, if you like, between a pair of wheels, you can use that to straighten the car up. So if a vehicle is intending to go in a straight line, if the driver is just requesting straight line driving and it detects a slip, then you can apply more torque on one side than the other side to help bring it straight again.
The benefit of electric is that with the level of control you have, you can limit torque, meaning that you can get fantastic traction and acceleration with limited, if any, slip at all.
It's time for Zeph to discover what this car is all about.
It's quite incredible. From a complete standstill now, with no engine noise, you put your foot down and it just crawls like an absolute baby. We could be in a car that had like 5 horsepower now. Crawls along, and then we put our foot down, and the thing just accelerates rapidly to 60 miles an hour. That probably felt like about 4 seconds into 60.
Yeah.
But you haven't been stingy on the power. It's 400 horsepower.
Yeah. We like to go fast.
Zeph's been set a course to demonstrate how GPS and the car's computer system work together to recognize and respond to the movements and speeds of the car.
Okay, Zeph, I want you to attack the slalom now.
Right, so everything now off, yes?
Yeah.
Right, let's see what it's like.
First up is the slalom, and Simon has turned off the vehicle dynamic system.
Yeah, a lot of slide, a lot of movement on the front wheels. You can feel that a little bit more, we'd have lost the front probably.
Yeah.
The car's all over the place. It's understeering, oversteering.
What we can do on the electrics here is change that software so that the steering feels more positive. We're differentiating the torque left to right. So I've now changed that in the software, touch of the button. And if you go through the slalom, you should feel the steering more positive. You can attack it even harder.
Okay, let's go for it.
With each tweak, different amounts of power are being sent to each of the wheels, improving steering response, allowing Zeph to go faster.
Wow, I mean, that's really night and day.
Yeah.
I mean, it really did feel far more level. Quite impressive, quite noticeable difference.
Next test is the constant radius, designed to demonstrate how the computer system helps to manage understeer.
I've turned the systems off.
Right, in drive.
Yeah.
Off we go.
Yeah, it's hard to make that radius.
Yeah. As we went faster, we had massive understeer, and we ended up towards the grass.
So now we've got the vehicle dynamics control on.
Okay.
So we're now differentiating the speed between the inside wheel and the outside wheel.
Right, stability controls all on.
Yeah.
By allowing the outside wheels to turn faster than the inside, the car is then able to stay in a perfect circle.
Wow. Definitely holding a much straighter line now.
Yeah.
I can feel the electric motors doing their work. It's quite a phenomenal speed going around the corner here. You can feel the car grabbing, biting, sliding, but we're still going around. It's a phenomenal circle. It kept control by changing the speed of the inner wheels to the outer wheels, like a limited slip differential. And now we got 4-wheel drift, but it's still holding you. Wow. That's definitely some good algorithms there on the computer, keeping it all in line.
Yeah.
Woo.
And we can smell the tyre rubber too.
We can. Unfortunately, the computer can't sort out the distance of my head. To the old school mechanic, it's quite mind-blowing the fact you can change the performance of the car, its handling and engine power just by changing letters and numbers on a laptop. A bit dizzy now.
Yeah.
I can smell some lovely rubber smell.
Yeah.
You see, even electric cars can still smell great.
Yeah.
Yeah.
Back in the Speed Freaks garage, the team are still grappling with how to convert a diesel Mercedes into a fully electric vehicle. The new electric components are big and bulky, so making more space is their first task.
Mark's cut the boot floor out. I've cut the firewall out, which is behind the back seats. So we've got literally a blank canvas to work to.
Hello, mate! Hello! Hello! Tunnel!
Mon Dieu!
They've made as much space as possible in the rear of the car, but they still need to work out how they're going to fit the motor between the chassis and the subframe.
This is the same subframe that we took out earlier, which was rusty, oily, and yeah, we just sent it up to our local sandblasting shop.
Now they have a better idea of what they're working with, the subframe goes back into the car for one last measure. But as the car is lowered onto the motor, it becomes clear the drive unit is in the way.
Whoa. Nothing fits. Nothing. It's going to be a really fun episode because me and Martin are just going to be staring at it a lot. When we go quiet, it's because we're thinking.
The problem with the motor is, because it's so wide, it basically takes the whole width of the chassis of the car, and on that motor, just in front of it is the drive unit, where the drive shafts need to come out to, and those need to be as in line as possible as the rear hubs. So basically, exactly where the subframe is sitting.
So the subframe comes back out. It looks like it's going to have to be modified.
We're going back now.
Cutting the subframe will make it weaker, but they've been left with no other option.
As soon as we've got our heads around the motor and cracked that issue, yeah, we should be able to move forward pretty fast.
Howdy ho!
They may have made space for the motor, but the frame will need strengthening. So Simon settles in for a long night of welding. Coming up, the Speed Freak's electric conversion starts taking shape.
Right, it's going. You just wire it up, mate. We'll see you in a week.
And Zeph gets his first look at the engine he hopes will power him to the Pendine record.
Oh, look at that beauty.
Back and lock.
That is lovely.
Zeph may have been inspired by the land speed record breakers of the past, but for his attempt, he's looking to the future.
The fastest cars on the planet all rely on the best electronics.
So the team are converting an old diesel into a fully electric vehicle to see what impact electric power has on performance.
Show us what it can do.
Come on!
The biggest challenge so far has been making space for the new electric motor, especially with the subframe sitting exactly where the motor needs to be mounted. So the subframe was cut to accommodate the motor, but this meant it needed to be reinforced.
The rear mounts used to be here. Now this is all shaped for the motor, but it's all plated as well because we need to keep a lot of strength in it. So it doesn't look the best, but it's strong, which is what we need. Yeah, it's taken shape today. Subframe. Done.
The time has come for the heavy motor to be mounted.
It's not going to work because it needs to go. Hopefully we don't break anything or don't hurt each other.
Right, if I hold it.
Right, where should this go?
Just put it on the round bit. Just put it on the round bit. Okay, the car's about to come down. Tense moment.
I think it's going to hit the car now.
Put it this way. Okay, Tess.
Is it the moment of truth?
Let's have a look.
Oh, okay. There she goes. She's holding.
No way.
Thank goodness. There was a few hairy moments at times, but we got there.
Motor mounted, it's time for the subframe to go back in.
This is the subframe going in for the last time.
There he goes. Like a glove.
Motor's in, subframe's in. Tidy.
Good job, Simon.
Lovely jubbly.
Let's go.
At least the motor fits, but the next head scratcher is fitting the even bulkier batteries in the engine bay. EV expert Chris has built a supportive frame for the massive battery pack. It's the perfect size for the batteries, but what about the engine bay?
You know what?
So close.
That pipe is like stopping it. To be honest, it was like, it would do if we just squeezed and banged and cut little bits out.
I think if we took a bit of the soundproofing off, push the pipe back in, it probably would drop in.
Cool, let's whip it out now. I will not be defeated.
Where there's a will, there's a way. Especially when you have a big hammer.
They call him the Terminator in the drift world because he looks like him.
Hasta la vista, baby. I'm just massaging the rear bulkhead to see if it'll fit some more. Right, we've had a lot of fettling. Now is to see if the bonnet will close with this box in there.
Yeah, loads of room.
Oh, like a glove. We've got the battery pack in the right place. I'm excited, it fits.
At last, it feels like progress is being made on the diesel to EV challenge. Over at Ibby's garage, the last time we saw the engine, it was removed and sent to a special facility for upgrades. The fully strengthened engine is back, and Zeph can't wait to get a look.
Ibby, how you doing?
Yes. Good to see you.
All right, good?
Yeah. Here she is.
Oh, look at that beauty.
Back at last.
That is lovely. So just remind me, we've gone from 3.8 to
4.1.
4.1. We've got special pistons.
Upgraded pistons, liners, O-rings, bigger crankshaft, conrods.
Strong conrods.
Yeah, the full works basically.
The full works, okay? And I understand you've got like a motorsport head on this now.
That's correct, yeah. So we've changed out the heads, the camshafts, that's all been replaced as well. We've upgraded the fuel system. We've upgraded the intake manifold. So yeah, a lot's been done.
And I see some very sexy turbos on the side here.
Big derricks, yeah. These are rated to approximately 700 or 800 horsepower each, so there's plenty of life in the turbos.
Tons of power,
Yeah.
okay. Now obviously my biggest concern is this is putting out nearly 3 times the power at the flywheel and the original OEM engine.
Yep.
How are you going to make that work with a clutch?
So we've upgraded the clutch packs as well. They're just there.
Right, yeah, this is my biggest concern.
This is a treat on its own. This is the party piece. This is what's going to allow us to basically run the power through the car. Here it is. There you go.
So this is a special...
So this is an upgraded clutch pack from Datsun Motorsport.
This is Datsun Motorsport, so they specialise in making very high-powered clutches.
That's correct, yeah.
For this particular PEK gearbox.
Yep, that's correct. So we can run these clutches up to 1,000+ foot-pound of torque.
And also, the big investment in this engine.
Yeah.
So we want to make sure that we've got sensors all over it.
Yeah, so to protect your investment,
Yeah.
I've actually gone ahead and ordered extra sensors. I didn't even check with you, but I'm sure you're not going to say no. What I've done is I've added EGT sensors to each bank, as well as EGT sensors, per cylinder, which will basically allow us to monitor the temperature, all the exhaust gas temperatures in the engine. So if the exhaust gas temperature gets too high, we know it's running lean. If it gets too cold, we know it's running rich. So we can adjust the fuel trims just so it basically runs. Yeah.
Ibby, you've done the most amazing job. I want to thank you.
You're welcome. Thank
I
you.
love what you've done. It's superb. Touch you soon.
Take care.
Thankfully, back at the Speed Freaks garage, there is enough space for the battery pack. But before it can be fitted, there are still a few more things to do. Everything from power steering to brakes relied on the diesel engine for power, which means a lot of electric-friendly parts need to be found a home too.
I am putting this vacuum tank, which is for the brake booster. What is this?
Flux capacitor.
No!
This may be the first electric conversion the team have done, but they're fast learners.
There we go.
We got power steering, we've got brakes, we've got brake lines. We're ready for insertion of battery.
There we go.
Woohoo!
Get this battery box out.
It's the juice for the Merc, the juice box.
They've decided half a Tesla battery with 30 kilowatts of juice should be all they need. But even half a pack weighs in at 240 kilos. The battery pack might be enormous, but underneath the cover, things are a little more recognizable.
So this is a Tesla Model S battery module, and these are the cells, the 18650 cell. They're found in laptops, vapes, all sorts of stuff. The Mercedes has got 3,960 of them. And then in here, as you can see, we've got our coolant system. So this coolant system loops up and down inside the pack to keep all the batteries at the even temperature. And this runs on normal coolant like you put in your radiator in your car. Everyone would think it's massively technical, but it is literally just a pile of cells glued and wired together with some coolant.
The design may be simple, but fitting a quarter-ton of lithium into a Merc's engine bay is not. There's not even a millimeter to spare.
I love it how I'm doing the pushing.
Contest, put your back into it. A little bit harder. Okay, you can go down at that.
Looks like Martin's measuring skills have passed the test.
Okay.
Da, 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 da.
We're done.
Right, let's go in. You just wire it up, mate. We'll see you in a week.
If we take these flaps off, maybe.
Battery pack in place, Tessa's now working with Chris on fitting EV-friendly displays.
The display basically tells us the state of charge of the battery, battery temperature, motor temperature. Also tells us the kilowatts we're pulling of power, as well as what gear we're in, so drive, neutral, reverse. Let's go somewhere like that.
We needed to fit a display unit into the car, so we put it in the centre console. We've cut out a section in a couple of the cubby holes that they've got. Well, Chris, look.
It's nearly straight.
Chris doubted my skills. Bless him. It's not too bad.
It will do.
Oh, it will do. I think that was quite good, actually.
Display unit fitted. Next on the to-do list is the control unit.
Hey.
There we go.
Another component the team need to create from scratch.
So I've made my little control unit. I've spray painted it. I've put all my little switches in. And now I'm going to mount it into this little hole. Hopefully it all fits. So that's all in. It's all coming together now. So, high voltage cable.
Yes, so this is our high voltage connector for the battery pack.
Yes.
So we're now going to run this in under the vehicle into our high voltage box,
Yes.
which then distributes it to everywhere that needs it.
A petrol car has hundreds of moving parts that distribute power. On an electric car, cables get power from the battery to the motor and finally to the wheels. It's as simple as that.
So in the rear of this car, we've put 2 chargers instead of just the one, because if we fitted one, it would have taken about 3.5 hours to do a full charge. So we've brought that down to about 1 hour, 15 minutes, roughly. Cool, so we should probably bring it down now then, and we can do the last connection.
Brilliant.
Excited.
It's all coming together now. It looks really cool with all the orange wires and the silver boxes in the back. I've never attempted anything like this before, and I think this is a great achievement. We're really happy.
The team have designed and built an electric car. The million-dollar question is, will it switch on? Coming up, the moment of truth for the team's diesel to EV conversion.
Boom.
I don't know if I should get an extinguisher ready.
And Zeph puts it through its paces at the Speed Freaks test track. On his quest to break the Pendine Sands record, Zeph Eisenberg's asking the Speed Freaks team to explore ways of improving performance in some very different cars. This week's challenge has taken the team well outside their comfort zone,
I just don't know how we're going to make this work.
exploring the world of electric cars.
Nothing fits.
They've managed to squeeze a Tesla motor and battery pack into an old diesel sedan.
Lovely jubbly.
Now is the moment of truth. Will it actually work?
Boom.
I don't know if I should get an extinguisher ready. One that's capable of dealing with electrics, obviously.
Right, so now we're going to turn it on and see if the wheels spin.
The moment of truth.
The moment of truth. So put ignition on, and we'll wait for everything to do its thing, shall we say. Get the display on.
Can't hear it.
We'll press the whole important start button and see what happens, shall we?
She can. She got some chops.
Sounds like an RB.
Right, so press the start button. Let's now see if it moves the wheels.
This is tense.
This is tense.
Jesus!
How your drive shaft looking, Mark?
That wheel needs balancing. Sounds like a washing machine on spin cycle.
That is cool.
We've got an electric car. An old school Mercedes is now an electric car. This is pretty amazing.
Obviously at the start it was given a rusty old pipe smoker, but now it's green, doesn't make a sound. Yeah, just whispers along.
The final stage of the project is the most technological and complex, but simplest to fit, the electronic control unit. Every aspect of the car controlled with a few taps on a keyboard.
We can adjust everything. We can adjust all the throttle parameters. It's just instant all the way through, which is really, really good. So you can just go out on track and just mess around and make adjustments as you're going. There's so many adjustments on here. So we can do IDC max, which is basically maximum DC power the motor's going to pull. So we can adjust this up and down to give us more power, basically. So we can push that up to 1200 amps, which is going to give us, what, 500-ish brake, or we can restrict it down to half of that. So it's really good for control.
Literally at a touch of a button.
Yeah, press a couple of buttons, hit enter.
This is like really cool because for years we've been tuning petrol engines, diesel engines, whatever, and now the future is here, and the likes of you guys are now tuning electric cars. So the future is bright for motorsport and tuning, really.
You can make the little tweaks and the little changes, or at a track day and you're like, I've just not quite got enough power, or
there's too much torque is spinning.
Exactly. Actually, you can just jump on your laptop or your phone, you can just log in and press a couple of buttons and it's done.
Yeah.
It's a proud moment, I think, for all of us, and we're really happy. So I can't wait to see this thing on the runway with Zach driving it, and his cheeks going like that. I never thought in a million years that I would be working on an electric car or creating an electric car out of an old Mercedes. And I'm so looking forward to Zeph driving this on the track.
The day has come and it's test time. It may look the same on the outside, but inside is a whole new EV machine.
Mercedes, we've turned her into an EV.
Very nice, very nice. Can we see under the bonnet?
Do it.
Show him.
Where the diesel engine used to be is half a Tesla battery pack. New electric-friendly brakes and power steering. Every spare inch of the engine bay has been used.
We've got loads of gubbins at the back to show you as well.
Let's go and see the motors.
The other heavy bits of kit are in the boot, the electronic control units and charging packs. Beneath that, the electric motor and Martin's re-engineered drive shaft to handle the extra power and torque.
So Chris, this kit that you put in from the Tesla can deliver how much power in optimum?
About 300, right?
Wow, that's a ton of power. So this is going to be a 0 to 60 traffic light smasher. Yeah. That's what we like.
How much has the electric conversion improved the Merc's acceleration?
Oh yeah, here you go. Acceleration is so much better now.
Oh, she's got a lick on!
Oh, that is lovely. 50 miles an hour, 55, 60.
That looked a lot better.
0 to 60, nice. What a difference, what a difference. It's fantastic, you put your foot down, 10, 20, 30, 40, 60 miles an hour within seconds. It's totally progressive, linear power. I love it.
Reckon you've done it?
I reckon so.
This is a very humbling moment for myself and the team. Look at what we've created, and it's done the job.
So, how was it?
How was it?
It was impressive.
It looked impressive.
The best thing is I don't have to hear that horrible vibrating turbo diesel anymore. 0 to 60 time, this thing did 7.5 seconds.
Amazing.
Massive congratulations to all of you. for the fantastic conversion job. You know?
Well done, everybody. Well done, Guy.
And you, Chris.
Yeah.
Yeah, well done, Chris.
But before we can give it a total thumbs up, let's have a benchmark. I was thinking BMW i3.
Zeph wants our Mercedes to go up against the BMW i3. Why? Because it's one of the most advanced electric cars on today's roads. With hundreds of millions of pounds in R&D, they've created a car with an electric motor that can produce 125 kilowatts, giving a 0 to 60 time of under 7 seconds.
I'm actually a little bit scared about this. That thing is built by BMW. They've probably spent millions in development on this thing, and it has a carbon fibre chassis. On paper, we should be losing this.
So, who's going to race me?
I fancy a bit of this.
Right, I'm in the BMW i3.
Yeah.
You're in that. Let's see who wins.
Awesome.
Before we burn rubber, Chris tunes the electric Mercedes at the touch of a button to give it a fighting chance.
So we want a little bit more on the start, I reckon. Let me put the throttle response up a little bit more.
Just by using a phone in the back of the car, you can change the speed, the accelerator pedal, anything you could possibly imagine at a knock of a button. It's incredible.
Here we go.
Come on.
This is it.
3, 2, 1, go!
Faster, faster.
Come on, Mac! He's still in front. He's still in front. I think I've still got him.
Accelerating, catching up on him.
Is he reeling him in?
Oh, he's reeling him in.
Yes! Oh, awesome!
Well done, Simon.
There wasn't much in that.
Wasn't much in it, but whatever I did, you were always a few cars ahead of me. I could not catch you up. You stayed the same distance the whole time.
Luckily for me.
It was impressive. What this challenge has shown is electric is here to stay, and it's only going to get better each and every year.
Yeah, it's definitely been a massive learning curve for us, and
Yeah.
we were kind of against electric as well before, but now we've embraced it. We're excited to
Yeah.
see how tuning these things goes, really.
It's quite clear with the amount of power we're going to be putting into the Porsche, it's going to have a standalone ECU, so I can tweak and modify the settings for the conditions on the day.
Really and truly, we couldn't have done this without Chris. So
Yeah.
Chris, thank you very much for all your help.
Chris.
Legend.
Awesome.
Thank you.
Spot on.
Wonderful.
Massive engineering.
And the best thing, Chris, is I've now got a nice, smooth, quiet car that I can relax in.
And it doesn't smoke.
Next time, Zeph improves his handling skills.
If that car goes out of shape, you've got to learn instantaneously, subconsciously, how to get that car back into shape again.
And stop, 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 stop!
And tyres become an issue on the land speed car.
They're big. I don't think these are going to clear the arches. Yeah, I don't think this is going to happen.